Okay, so we're going to do 9.3 part 2 tonight. Make sure you have your notes out and you're taking notes. Remember, if for some reason it does not show up on my Educanon that you watched all of this and you answered the questions, you're going to need to make sure that you can show me notes for that. Okay, so be very clear in your notes. If you also want to jot down some of the questions with the answers, that would be helpful as well. All right, so let's get started. If you're in period 4, today we started working on some examples from the book where you had to show not just the equation, but also when you take out spectator ions, okay? If you have questions on that, we will go over it tomorrow in class. But for right now, we're just going to work on what else can happen in aqueous solutions. All right, so some reactions produce more water molecules, and some of you saw that in the examples you came up with your double replacement reactions, where one of your new products was water. Okay, when this happens, there's often no evidence of a chemical reaction, because if you look here, okay, this is happening in an aqueous solution, so it's already in water, and this is aqueous, and then we make water, okay, and this is aqueous. So we really aren't seeing what's happening here because we have water, 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 and more water is being formed. Without spectator ions, this is how we would write the equation. So we would say we have hydrogen, and we have hydroxide, and we end up with more water, okay? And some of you might question, why is this hydrogen on its own? Why is it not diatomic? That's because we've just taken it from here, okay? We've taken it from the bromic acid, and so it is on its own. And if you notice here, it has a positive, so it's an ion, so it can be written that way. All right, the gases that are commonly produced when we have reactions in aqueous solutions are carbon dioxide, so CO2, carbon cyanide or cyanic acid, and hydrogen sulfide or hydrosulfuric acid. Okay, and if you look here in this example, okay, we have 2HI in an aqueous solution plus lithium sulfide, again, aqueous solution. And we end up here producing hydrogen sulfide, or hydrosulfuric acid. All right, this is a gas. So remember, there are 3 things that can be formed in a double replacement reaction in water, either more water, gas, or precipitate. Another example is if you mix hydrochloric acid and baking soda, which is going to give you carbon dioxide gas. So here we have hydrochloric acid, okay, aqueous, so it's in water. We add that with the baking soda or sodium bicarbonate, and then we end up here with carbonic acid and sodium chloride. So you have to ask, why does it say that this produces carbon dioxide gas? Do you see that anywhere? No, it's because this is now a 2-step reaction. Okay, so here is our original reaction that we saw, and what you need to know is that this carbonic acid is decomposed then, and that's when you end up getting the water and the carbon dioxide gas. So this is a 2-step process reaction. Okay, so if you look at it this way, we have a double replacement reaction that's immediately followed by a decomposition. So 2 reactions can be combined and represented by a single chemical reaction. So these are the two reactions done separately. You have the double replacement here, and then you have the carbonic acid that goes down and is immediately decomposed into water and carbon dioxide. Okay, so you end up with 3 products here in reality. The sodium chloride, the water, and the carbon dioxide gas. So reaction 1, as we saw earlier, reaction 2, so we have a double replacement reaction here. We have a decomposition reaction here. And then you can see when you combine the equation, you have hydrogen chloride plus the baking soda, the sodium bicarbonate, plus the carbonic acid, which then breaks down into, excuse me, which breaks down into carbonic acid again, plus sodium chloride, plus water, plus carbon dioxide. And yes, the carbonic acid is both a product and a reactant because we've combined these two reactions into one. Okay, so the overall equation, when we get rid of the things that are both on each side, so we end up with hydrochloric acid plus baking soda, which gives you water plus carbon dioxide plus sodium chloride. Okay, so I hope that makes sense to you. I hope that the idea of putting two reactions together to make a combined reaction and then going through and crossing out the things that that are the same. I'm sorry, that was the wrong thing to cross out. Crossing out the things that are the same in both of those makes sense, and we'll talk more about it in class tomorrow, okay? Make sure that these notes are all complete. Make sure that you've jotted down some of the questions in case EduCanon messes up and shows that you didn't do it. If you did not do the EduCanon from the night before, 9.3 Part 1, please make sure that you do that as well. All right, have a good night.